the Cozy Rainbow Podcast time.
Hi, everybody. Welcome to the Cozy Rainbow Podcast. My name is Tammy, but my students know me as Miss Tammy.
My name is Joe, and I'm suddenly feeling 27 seconds younger.
On today's episode of the Cozy Rainbow Podcast, we're going to talk about leap seconds. Now, you've probably heard of a leap year, but what about a leap second? Well, let's get into some trivia questions about it. Joe, starting with number 1, what is the most accurate type of clock? Is it A, a wristwatch, B, a grandfather clock, C, an alarm clock, or D, the atomic clock?
The atomic clock!
Number 2, what causes the ocean's tides to push and pull? Is it A, solar days, B, Atlas, the Greek god of the sky, C, swimming patterns of fish, or D, the moon's gravitational pull?
D, the moon.
Okay. And number 3, true or false? A bunch of leap seconds adds up to a leap year.
Yeah, well, I suppose if you had enough of them, then, sure, but... I mean, that's a lot of seconds, you know? This is a really weird question. I mean, false. Sure, false.
Okay. We're going to get into the answers of those trivia questions and some more fun facts about leap seconds and what exactly are leap seconds right after this quick break. Joe, do you want to know a silly little thing about time?
Yeah, I would like to know some silliness with time. It seems so boring and dry. It's just these clocks just ticking.
Yeah, I agree.
Ugh.
The clocks we use are so precise that every so often we have to adjust them because they are actually too precise for the rotation of our planet. Earth. You might know it.
What do you mean? What do you mean is a clock I don't know. The Earth's a big thing. You telling me a clock is better than the Earth spinning?
Well, it's not better than it, but we have to find some type of way to...
Better at being consistent?
Okay, sure.
Better at being regular?
Sure. The rotation of our planet is slightly slower than our precise time. For example, the clocks that keep time in the United States, Russia, China, Zimbabwe, Peru, and all other places never slow down. They always keep the same pace of time no matter what. These are atomic clocks and they are extremely accurate. They're so accurate that they don't always align with the time it takes for the sun to rise and fall for a given solar day. Because the sun actually is what determines our days, not our iPhones. If I were to ask you how long a day is, Joe, what would you say?
I'd say 24 hours.
And if
Except on daylight savings, in which it is 25 or 23, depending on whether it's starting or ending.
Okay. If you answer 24 hours, you are short by 0.0000006 seconds. I would say that is a fraction, but I don't actually know. Hold on, I have to pause it to figure out what the fraction is.
Which
7 decimal places?
7 decimal places, which should be...
We have 10, 100, 1,000, 10,000, 100,000. What's after 100,000? Million?
A millionth.
What's after millionth?
10 millionth.
10 millionth. So 6/10 millionths of a second. That's you're wrong. You're wrong by 6/10 millionths of a second, Joe.
Ah, darn.
And everybody else who answered 24 hours.
Except when I said 23 and 24, in which case I am wrong by an hour and 6/10 millionths of a second.
Right. Okay.
How embarrassing.
How embarrassing. How are you going to show your face again? Oh,
Actually, well, no.
You don't have to.
I was wrong. Oh, haha. Anyway, I was wrong in one direction by an hour and 6/10 millionths of a second. The other way, I was wrong by an hour and 0.99999.
Okay, I don't
Yada,
even know
yada,
what you're
yada.
saying. So our day is actually just a little bit longer than 24 hours, but this extra time is so small that it almost doesn't matter. Almost.
Sick. So I was actually right. Good job, me. Good job.
Right about what?
I was right because you just said the 60 millionth.
What?
Or
610 million
610 millionths
of a second.
of a second didn't actually matter. So actually, I'm right.
Oh, no. I said it almost doesn't matter.
Yeah.
But it does. Because over time, that extra little time adds up. Meanwhile, the clocks we use to measure time never really change. They don't know. They don't know about the 610 millionths of a second. After a while, our atomic clocks get too ahead of the sun. When that happens, we have to add an extra second to the clocks that we use. What? We can just add one like that? We call these leap seconds. Now, leap seconds that might sound similar to something you may have heard before. The leap year. Do a bunch of leap seconds add up to a leap year? I'm afraid not.
They come from two very different places.
They're not even in the same league.
Not even in the same
They're not in the
century
same
of
room.
discovery.
Oh, wow. Yeah, that too. Leap years happen because of the relationship between the Earth and the Sun, whereas leap seconds happen because of the relationship between the Earth and the Moon.
See, when Pope Gregory, or if I'm remembering that right, when Pope Gregory invented the Gregorian calendar, his astronomers were like, but a year's not actually this many days. It's this many plus a little bit extra. So if we just let the calendar ride like this, we'll be wrong in like 4 years. Mm-hmm. And then somebody had the brilliant idea of going, we'll just put an extra day. And so they did.
And thus the leap year was born. So, the moon is large enough to affect the Earth's rotation. The pull that the moon has on the Earth is called the gravitational pull. This gravitational pull creates a big bulge of water kind of in the ocean, and it's so big that you can't really see it. Instead, we see the water changing along the shores. We call these tides. You may hear people say that the tides are rising or the tides are falling. It's not really that the water level is changing. It's that the Earth is rotating into and out of that bulge of water. If we are rotating in to the bulge of water, the tides look higher. And if we are rotating out, the tides look lower. Because the moon is collecting all this water with its gravitational pull, it affects the speed of Earth's rotation. Think of it as the tides dragging the Earth just a little bit. This drag and other forces make the rotation of the Earth less precise than our clocks would have us think. There's nothing slowing our atomic clocks down, so they get ahead of our planet's rotation. When our clocks get too ahead, that's when we humans insert another second into our clock's day. We humans have only been doing this for about 50 years, but many meteorologists have agreed to stop using these leap seconds by the year 2035. However,
What are we going to do instead?
yeah, exactly. It's not clear how we will keep track of these differences in our clock time and our solar time after that.
I can't do this. I can't live with an imprecise day. I need midnight to be midnight, and I need noon to be noon.
I think we should just do away altogether with daylight savings time.
Why?
Why?
You live in the desert. See, you don't understand the value of daylight savings.
You're right, I don't.
But
If Arizona doesn't have it, neither should we.
if you live in a place where you see the point of daylight savings,
You see, isn't it so you can have an extra hour of sunlight in the morning
yeah,
for the farmers?
it's in the morning. No, well, not necessarily for the farm. Just an extra hour of sunlight, just in general. Just during the summer months, you get an extra hour, and also more importantly, the entire clock gets shifted forward a little bit. So you're getting up earlier, you're getting out of work earlier. You can be outside and in the sun for a bit longer during the summer months when it would be nice to do that.
Yeah, I think that it should just be, we should just have an extra hour of sunlight all year. Why doesn't that happen?
You're going to have to file a complaint with God then.
What?
Extra hour of sunlight all year is, well, whatever. You live in the desert.
No, I don't understand.
You live in when, you see, in some places it gets cold in the winter.
It gets cold. It gets cold here.
Yeah, but it's like 60 degrees. People are going to laugh at you for saying it's cold. Our listeners from places that aren't deserts are going to laugh at you for being like, 60 degrees is cold.
Listener, if you're laughing, write in. Just kidding, don't. But we have to do the trivia questions, Joe.
Well, okay.
Okay. Number 1, Joe, what is the most accurate type of clock?
An atomic clock.
Good job. Number 2, what causes the ocean's tides to push and pull?
The moon's gravity.
Mm-hmm. Good. And true or false, a bunch of leap seconds add up to a leap year?
False.
False. But I guess I didn't really consider it the way that you were saying in the beginning, where technically, I guess if you wanted to, you could put that many leap seconds together, but like that's not how it works. That's not how leap years are made.
27, in total, as of right now, 27 leap seconds have been added to our clocks. So we have...
Are you for real?
Yes.
How do you know that?
I Googled it.
Common knowledge. Oh.
Anyway, but 27 leap seconds have been added to our clocks. So we have a nice leap half minute going.
Oh, yeah. So we could never. So it would
rounding
take
up, obviously.
It would take a long, long time to be able to build a leap year.
Yeah.
Out of leap seconds.
When did leap seconds start happening? Was that something in the episode? I forget.
I don't think I said that. No.
1970.
I would just guess around the time of the globalization of clocks.
I think the globalization of clocks and the invention of atomic clocks are two very separate.
Okay, fine. That's
anyway.
The atomic clock is what I mean. I guess whatever. Anyway, if you are a teacher in a classroom and you would like to listen to this podcast as a lesson with your students, help them learn how to take notes, help them absorb all of the things that we mentioned, maybe even map out all the places that we talked about on a map. You can learn where Zimbabwe is. You can make a timeline of all the years that we mentioned of events in this podcast and many other fun things. Some of these worksheets are available for free on our website at cozyrainbow.org. We also have a Teacher Space Teachers store. You can search up Cozy Rainbow. And if you would like to write in or, have a comment, question, or concern, you can email us at cozyrainbownv@gmail.com. All right, everybody. Thanks for listening.